Those same rules help us check symmetry with respect to the y-axis. The graph of y equals f of x is symmetric with respect to the y-axis if, for every point xy on the graph, the point negative xy is also on the graph. So f of negative x equals f of x for all x in the domain. Such a function is called an even function if f of negative x is the same as f of x. With respect to symmetry with respect to the origin. Now this was the y-axis, so basically they're saying it's the same on both sides of the y-axis. This is symmetry with respect to the origin. The graph of y equals f of f is symmetric with respect to the origin if for every point xy on the graph, the point negative x, negative y is also on the graph. So in this case, f of negative x equals negative of f of x. And this is called an odd function. Now, symmetric with respect to the origin, there's the origin. If I have this point, I have this point. If I have this point, I have this point. That's respect to the origin. And with respect to the y-axis, the graph is symmetric to the y-axis if for every point xy on the graph, the point y, x negative y is also on the graph. So this is one that might look like this, although that is not a function. So it has to look, that's a little bit of a problem because it doesn't make it a function. Now we're going to determine algebraic where the graph of this is symmetric to the x-axis, the y-axis, or the origin. What I want to check is I want to find f of negative x. So wherever there's an x, I fill in a negative x. So f of negative x becomes 3 times negative x squared over 2 times negative x quantity squared minus 1. Well, negative x times negative x, the negative times a negative becomes a positive, and that just becomes 3x squared. 2 times negative x squared, well, negative x times negative x turns into positive x squared, so I've really just got 2x squared minus 1. So in this case, these two are equal. So f of negative x equals f of negative x. So I would say, in this case, with respect to the x-axis, for x-axis I want xy to give me x negative y. So for the x-axis, I would say no. For the y-axis, I want x negative xy to give me the same as xy, so that is a yes. And for the origin, I want it to be negative the whole function, so I'd want the negative out here. So the origin, I would say no. So we have a no, yes, no, and confirm that graphically. Well, here it is with the graph. Is it respect to the x-axis? No. That agreed with my no. The y-axis, along here, if I folded along the y-axis, would they match up? Yes. The origin? No, just as we confirmed. Again, we'll check. We will find f of negative x. So 2 times negative x cubed minus negative x. Well, negative x cubed, negative times a negative still turns into a negative x cubed. So this will equal negative 2x cubed, and a negative times a negative makes it a positive x. this is actually equal to negative f of x. Notice that the signs both change. This was a positive, negative, it's a negative, positive. So this is a yes for the origin. It's a no for the y-axis, and it's also a no for the x-axis. Check it graphically. So looking at the graph, if I folded along the x-axis, would it match up? No, as we suspected. If I folded along the y-axis, would it match up? No, as we suspected. But the origin for this point here, I have the matching point across, going across the origin. For this point here, I have a matching going across the origin. So that was a yes, and we have confirmed our suspicion. Now this is an interesting one with respect to the x-axis, the y-axis, and the origin. I'm going to check f of negative x. So negative x, the quantity squared, plus y squared equals 25. So that would be an x squared plus a y squared equals 25. So that is a yes for the y-axis. If I filled in negative x and negative y, I would still end it with x squared plus y squared equals 25. So that's a yes for the origin. And if I filled in x negative y, I would still get x squared plus y squared equals 25. So that's a yes for the x-axis. So we found a yes for all three. That's interesting. Let's look at this graphically. Oh, it's a circle. So if I folded x-axis, if I fold along here, this would be a yes. Y-axis, if I fold along the y-axis, that would be a yes. And the origin, basically, if I fold along this line or this line, I'd get a yes there also. Now notice they ask about an equation. And this equation has symmetry, but is it a function? No, because it does not pass the vertical line test.